2, conservation of momentum. Here we're going to talk about an inelastic collision. So let's read the following problem. A 1,500 kilogram car traveling east at 20 meters per second collides with a moving 2,500 kilogram truck after they collide. The two interlock and move together with a velocity of 30 meters per second west. What was the original velocity of the truck? Hint, draw it out and indicate which direction is positive and negative. So I have a 1,500 kilogram car traveling east at 20 meters per second. It collides with another moving 250 kilogram truck. After their collision happens, they interlock, which means that they are stuck together, and they move together with a velocity of 30 meters per second west. What was the original velocity of the truck? Again, we always know the hint, draw it out, and indicate which direction is positive and negative. So I'm going to do my never eat sour watermelons. We know that anything going west is negative, anything going east is positive. So now let's draw it out. So when I have an inelastic collision, I have before and I have after. Okay, so before I have two objects, M1, which is 1,500 kilograms, and object 2, which is M2, is 2,500 kilograms. Okay, so the 1,500 kilogram car is traveling east, so that means my velocity is going towards the right, 20 meters per second. They don't tell us what the truck is doing before the collision, so V2, we don't know. After they occur, the trucks interlock. So now I have them stuck together. So you can just draw them like that. So I have M1, which is 1,500 kilograms, and M2, which is 2,500 kilograms, right? They're stuck together and they're moving with a velocity of 30 meters per second west. West is to the left. So that means that the velocity that they're moving with is negative 30 meters per second, because that indicates it's going westwards. These objects are now together. They're acting as one object technically. So what you do to justify that their mass was combined was just put a plus sign, right? You're adding them together. They are combined masses now. And these objects are moving with some ending velocity, which we refer to as the final velocity of objects. Okay? So then once we do that, it's time for us to make an equation. So every object has its own momentum, right? We know P equals mv. So for object 1, we say m1v1 plus m2v2. However, now they're interlocked. So now we say, all right, well, m1 is combined with m2, and they move together with some final velocity. So that's the formula we're actually going to use to calculate this stuff. So just like in the other video, we're going to write out our givens initial. That's my before. And we're going to write out my givens final, which is the after. Okay? Then we'll be able to figure out what's the unknown. So my M1 was 1,500 kilograms. M2 was 2,500 kilograms. V1, we know, was, 20 meters per second. They didn't tell us any information about the truck's initial velocity. We know that M1 is still going to stay the same, right, because mass never ever changes. M2 is still going to be 2,500 kilograms. I don't know why I put a parenthesis there. Let me delete that. And this final velocity that they're moving together with is negative 30 meters per second because it is traveling westward. So again, we see the hole is right here. So we know that V2 before the collision is the thing I'm going to be looking for. So now we're just going to rewrite the equation that we, came together before with this, right? So now we're going to rewrite this, and we are going to plug and chug, and we're going to figure out our answer. So we say that M1 V1 plus M2 V2. Again, this is my velocity. That's my momentum for my first object. This is my momentum for the second object, but that's before the collision actually takes place. And then now these objects are interlocked, right? So now we have VF times M1 plus M2, right? Because my masses are combined now. They're traveling with some final velocity together. So again, this is before. This is after. Okay, so now we're going to substitute. So I have 1,500 kg. times 20 meters per second plus 2,500 kg times v2 equals negative 30 meters per second plus 1,500 kg plus 2,500 kg, right? Because my masses are now combined. So now let's clean up this side right here, right? This is where all my numbers are. Let's clean that up because it kind of looks pretty heavy going on over there. So we do negative 30 times 150, or excuse me, 1,500 plus 2,500, and you should get that this side of the equal sign is equal to a negative 120,000. So now, after we take care of that, let's move on to this right here. Let's clean this up. So 1,500 times 20 is 30,000 plus 2,500 V2. So let's isolate this. So we do inverse operations, 30,000, subtract on both sides. If you subtract a negative number by another negative number, it's going to continue to get more negative. So negative 120,000 minus 30,000, that'll give you negative 150,000. In order to break this up, they're combined by multiplication. You divide, because that's the inverse operation of multiplication, and negative 150,000 divided by 2,500 is negative 60 meters per second. And that should make sense because that negative 60, what it means is that my object was actually moving this way before the collision, and then they got stuck together after their collision. And to check to make sure that P before equals P after, right, we know that this side is negative 120,000, and we know that that was 30,000. So all we have to do, and actually let me rewrite this. So we have 30,000 plus 2,500 times negative 60 equals, and I'll put my minus 120 there. If we were to check that out, we say 30,000 plus 2,500 times negative 60, and we would actually get that it's negative 120,000 equals negative 120,000, which is exactly what we want to see. So momentum is conserved in this inelastic collision, which is very much true. If not, you'd be violating a fundamental law of physics. Okay, so again, just like before, draw out your picture. It's very easy to create an equation from a picture, and then from there, you know how to substitute and solve for a solution.